Good morning, everyone. I am Steve.
And I'm Scott.
And together we're Backyard Musings broadcasting live, Apple Valley, California.
Beautiful day, and we are the Science and Technology Channel.
The bees, they're out there pollinating because we got pollen, that's for sure.
Yeah.
And the birds are singing. You can hear them.
Yep.
Can't hear the crows, though. Thank goodness for that.
Yeah, it's a beautiful day.
They must have went undercover.
Slight little breeze. Yeah, it's good. Good day. Good day in the high desert.
All right, got a story about the moon. Chinese scientists analyzing samples from the moon's far side have uncovered that its mantle holds significantly less water than the near side, a finding that hints at a deep internal divide within our celestial neighbor. This discovery, based on basalt samples returned by China's Chang'e-6 mission, offers new insight into the moon's mysterious formation and evolution. Now, we reported on that before, right? When proto-Earth slammed into Theia, or the Earth, proto-Earth slammed into Earth, and then it created an accretion disk, which eventually formed into the moon. We've talked about that.
Okay.
It could even reshape theories about the moon's violent origins and how water shaped its interior over billions of years. The research led by Professor Hussein from the Institute of Geology and Geophysics at the Chinese Academy of Sciences was published on April 9th, 2025 in the journal Nature. Would you like to know more?
Chinese scientists have found that the moon's mantle contains significantly less water on the far side than on the near side, based on a new analysis of volcanic rocks collected by Chang'e-6 lunar mission. The team examined basalts from the lunar far side and found that their mantle source contains only 1 to 1.5 micrograms of water per gram, far lower than levels typically found on the near side. This discovery could provide important clues about how the moon formed and how its interior evolved over time.
Yeah, so I forgot to mention, the slide that you're looking at right now is showing the far side and the near side, and China has been investigating the far side for a minute now, and we know a lot about the near side. So this is interesting that we're getting more data. Previous studies, it seems like it would be opposite for me. Like, you don't have the sun over there melting, so the ice just stays.
But it's drier.
Yeah.
Right?
It's counterintuitive. I don't know. See, that's why I'm not the expert.
Cooler, I guess. Cooler.
Not
drier.
Yeah.
Cooler because it's the opposite side of the sun.
See, that's why I'm not the expert. You know what I'm saying?
I'm not the expert either.
No. Previous studies of near-side lunar samples have shown that water in the moon's interior is unevenly distributed, with concentrations ranging from about 1 to 200 micrograms per gram. Notably, the crust exposed at the surface of the Procellarum creep terrain. Did I pronounce that right?
What was that measurement you just said?
Procellarum, micrograms per gram.
Micrograms per gram. Okay.
Yeah, that's the Greek symbol for micro.
Gotcha.
It's like 10 to the minus 6.
Okay.
The surface of Procellarum creep, and this creep is all caps, KREEP, terrain, TERRANE, terrane, on the lunar near side has a higher thorium TH concentration than the other two primary lunar geochemical provinces, the feldspathic highlands and the South Pole Aitken SPA basin on the lunar far side.
Both TH and water are considered incompatible elements during magmatic processes, meaning they preferentially remain in the melt rather than becoming incorporated into crystallizing minerals. This geochemical behavior suggests that the mantle beneath the SPA basin on the lunar far side may contain a lower abundance of water. To confirm this hypothesis, the research team focused on analyzing water content and hydrogen isotopes in melt inclusions and apatite within CE6 mare basalts. The first samples returned from the far side SPA basin.
Now, I did not know that they were bringing samples back to Earth. I did not know that. That is fascinating, completely, instead of just analyzing there on the spot.
Okay, so just a little back and forth here. So everybody believes this story, but they don't believe that we landed men on the moon in the 60s.
No. Didn't have
in
the
the
technology
70s.
in the 60s.
And the 70s.
I mean, all the computer
Just
stuff.
shows you how far advanced we were. Just saying. Go
Okay,
ahead.
folks, if you don't know, I've got dry humor, so I like playing it straight faced. All the components in that Apollo whatever could be put into a cell phone right now. And you're saying that took our men to the moon and landed them on there? That's what you're saying.
I do. Multiple times. Multiple times.
Okay. All right. We'll go with it. The team's results indicate that the parent magma of these basalts contains 15 to 168 micrograms per gram of water. Additionally, the team estimated that the mantle source of the CE6 basalts has a water content of 1 to 1.5 microgram per gram, significantly lower than that of the nearside mantle. This disparity points to a potential hemispheric dichotomy in the moon's internal water distribution, mirroring many of the asymmetrical features observed on the lunar surface.
This new estimate of the lunar farside mantle's water content marks a significant step forward in refining our understanding of the bulk silicate moon's water inventory. That's okay. It provides important constraints on the giant impact hypothesis of the moon's origin and underscores the role of water in the moon's long-term evolution. Okay.
This study was conducted in collaboration with Nanjing University and supported by the Natural Science Foundation of China, the Strategic Priority Research program of the Chinese Academy of Sciences, and other funding agencies. So you're probably wondering, Steve, who cares? Why do I care of the water on the near and far side? We talked about it before.
We care that there's water on the moon because that's a sustainable, that's essential, right?
You need it to drink. You need it to break down into oxygen to breathe and hydrogen for fuel. Right. And and rather than carry that with you
you couldn't
to
carry
go to
enough.
You couldn't carry enough.
And you can't make water, right?
Well, if you're Harry Potter, you could.
Well, okay, but there's only one of him.
Right.
And he's not going to the moon.
Right, he's not.
But yeah, so you can't make water, so you got to find it there, right?
So we got it on the moon, and we use that to get to Mars. And if there's water on Mars, we use that to get to Jupiter or Uranus or Neptune or Pluto or another galaxy.
And is water a makeup of hydrogen?
Yeah, H2O.
Yeah. So we can use that, and we've talked about it in the past as far as using hydrogen as a fuel, right?
Yeah. It breaks down. So you drink it, and then you break it for the oxygen to breathe and the hydrogen as fuel to, propulsion.
And we are not engineers, and we are not experts. We're just
repeating.
We're just opining.
We're like parrots, repeating what we've read.
Just opining from what we've heard and read, right? Yeah. So cool stuff.
Okay.
But it's too bad.
Was I starting to sound like an expert?
No.
I don't mean to sound.
No. We're just having a conversation. So
okay.
It's too bad that it wasn't from
the
University of someplace in the U.S. rather than China.
Chinese.
But you know what?
Now, we're not Chinese apologists.
I'm not apologizing for them. I'm not criticizing them.
Communists.
It would be nice.
I'm going to assume propaganda.
Yeah, I'm going to assume that those people involved in this are probably not big fans of the CCP, but I don't know. Maybe they are, but whatever. It's all good. It's all in the love of science, right? That's what we're talking about.
Right.
So,
all right, folks. Thanks for joining us. We'll catch you on the next one. Stay tuned. Hey, and I guess if you click the like button on these videos, it affects the algorithm, so it makes it available for more people. So I was gonna have you click all the likes on our past videos. I might pay a teenager to do that too.
I got nothing but time on my hands.
Yeah. You retired, right?
Yeah.
Okay. All right, folks. Thanks.
Take care, everyone. Thank you.